Hey everybody, welcome back. Today we're going to be talking about standard P3B, which again is dealing with radicals. Our objective today is that you'll be able to simplify radicals by adding, subtracting, and multiplying, and you'll be able to rationalize the denominator. The rationalizing the denominator is really the part we're going to focus on today. In yesterday's video, we dealt more with the adding, subtracting, and multiplying. So before we can talk about what rationalizing the denominator is, we got to first understand what rationalizing is. So rationalizing is simply just the act of simplifying in order to eliminate a radical. Now, we can eliminate radicals primarily by multiplying by the same radical. So in this situation, we have the square root of a being multiplied by the square root of a. Now, as we discussed yesterday, whenever I multiply radicals, I just multiply the insides and the outsides together. Since there are no outsides here, there's nothing to multiply on the outside. Now, multiplying this together, a times a would give us an a squared on the inside. Now, the thing about square roots, this is a square root here. Whenever you take the square root of a number that is squared, they cancel each other out. A simple example of this would be if I had, let's just think about it like this. So 4 squared is really equal to 16, right? So if I was looking at the square root of 16, we know that since 4 squared is equal to 16, we can simply just replace 16 with 4 squared. So this is really equivalent to the idea of the square root of 4 squared. Now, again, since there is no index on this, we can assume that our index is 2. And what happens here is, well, if we think about the square root of 16 here, we know the square root of 16 is really equal to 4. So what that means for us is that this square root and this squared must actually cancel each other out, and we're really just being left with whatever is inside. So we're going to utilize that fact today in order to do what we call rationalizing the denominator. Below, we'll see some problems where our primary objective here is to go through and rationalize. So here's our first problem that we're going to be tackling today. And when we say rationalizing the denominator, what we mean by that is rationalizing means to get rid of the radical symbol. And the denominator is, of course, the bottom of a fraction. So what we want to do is we want to make sure that when we simplify this, or that we simplify this, in a way so that there is no square root on the bottom of this fraction. Now, again, this is a square root here, right? So the way we're going to go about this is we're going to multiply by what I call a fancy looking 1. So we're going to multiply top and bottom by the square root of 8. Now, in math, we've been doing this for a long time using this fact. We know that anytime I have something divided by itself, it's really equal to 1. And in math, we also know that if we multiply anything by 1, it's equal to exactly what we started with. It doesn't change. So we're not breaking any mathematical rules by doing this. Now, the way we multiply fractions is we multiply straight across in the numerator and in the denominator. Now, since 4 is an outside number and the square root of 8 is an inside number, those two numbers won't change one another. They just have to simply be put next to one another. So 4 times the square root of 8 is really equal to 4 square roots of 8. On the bottom, we have the square root of 8 times the square root of 8, which would give us the square root of 64. Now, if we've done this all correctly, the square root of 64 should break down. And in fact, we do know that that does into 8, because the square root of 64 is 8, meaning we are left with 4 square roots of 8 over 8. Now, if you didn't know the square root of 64 was 8, you could go through and break this down the way we have been. Look first at the prime factorization. So 2 and 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. And remember that means I can rewrite the square root of 64 as being equal to 2 times 2 times 2 times 2 times 2 times 2. And just like we were doing yesterday, anytime I have a pair of 2's or a pair of the same number, I can pull it to the outside, right? Doing the 2 for 1 special. So I'm going to have 3 2's on the outside, and those get multiplied together to give us 8. So in fact, we can see that the square root of 64 is in fact 8. Now, there is a little bit more simplifying we can do here. Whenever we have outside whole numbers here, right, 4 and 8 are both what we call outside numbers. They're not inside a radical. Those can actually be reduced. So reducing those like we would a fraction, we know that each of these can be divided by 4. So we can make this into 1 over 2 to start. And we also have the square root of 8. Now, in all radical problems, we always need to simplify our radical if possible. So if I take 8 and I go through and do my prime factorization, we find out that 8 is really just 2 times 2 times 2. When we do our 2 for 1 special, as long as I have 2 of the same thing on the inside, I can pull 1 to the outside. I'll be left with 2. And then since this guy didn't get paired up, he has to stay inside. So really, now I'm left with 1 times 2 square roots of 2 over 2. And of course, 1 times 2 is really just 2. So I get 2 square roots of 2 over 2. And if we look at that one last time, we notice, well, hey, 2 and 2, both of those are now outside numbers. So we can divide by 2 and divide by 2. And essentially, those cancel each other out, leaving us with just the square root of 2. So big picture here, when we actually rationalize, we take an expression that is more complicated to look at, and often it can be turned into something much simpler. Let's take a look at another problem. Again, the process I want you to first understand here, the simplifying is going to come. That's going to all come back to you as we do more of these problems and we practice. But the big picture idea here is really what is happening right here, where we multiplied by that fancy looking 1 to ensure that the square root on the bottom canceled. Now, down here, again, we see that we have a square root in the bottom, and we're saying right now that that's not okay. The way we're going to get rid of the square root in the bottom, right, if I want to get rid of that square root of 6, I need to multiply by the square root of 6, and I have to do that to the top and the bottom, because really, what I'm multiplying here has to be equivalent to the idea of 1. If that's not a big giant 1, then this does not work. Now, across the bottom, the square root of 6 times the square root of 6 is the square root of 36. And 2 times the square root of 6 would be 2 square roots of 6. The square root of 36 is, of course, 6. So I get 2 square roots of 6 divided by 6. One common mistake that you are not allowed to do, we can't cancel out these 6's right now. And the reason for that is because this is an inside and this is an outside. And those aren't alike, so we can't cancel those like we normally would. But one more thing we are allowed to do here is we are allowed to look at our 2 outside numbers, 2 and 6, and say, well, can those be reduced in any way? And of course we look at that and we say, well, yeah, 2 goes into 2 and 2 goes into 6, so that can be reduced to be 1 square root of 6 over 3. And this could be our final answer. It is important to note that this 1 is a take it or leave it piece. You don't have to sit there and have that 1. You can, though. It doesn't make it right or wrong. And again, the last piece is these 2 cannot be reduced because, again, 1 is inside and 1 is outside. Let's take a look at another problem. Here's another one for us. A little bit more complicated. Now we're seeing a variable and we're also seeing this coefficient on the outside here. Now, in order to rationalize, what we really want to do is we just want to make sure that we get rid of the square root in the bottom. So that's all we're going to concern ourselves with. We're not going to worry about this negative 6 here. We'll deal with that when it comes, but the piece we need to worry about is this square root. That's what rationalizing the denominator is all about, getting rid of that. So in order to get rid of a square root, as we saw in this first rule up top, to get rid of a square root, you need to multiply it by the same square root. And essentially, those 2 square roots are going to cancel each other off, and we'll be left with whatever was inside. So, since the square root we are trying to get rid of on the bottom is the square root of a 3a, we're going to multiply top and bottom by the square root of 3a. Now, it's important to note that in all of these problems, we're not trying to get rid of the square root in general. We just want to make sure there's none in the bottom, which is why we still had a square root as an answer. We still had a square root, but it was in the top. Our goal is to make sure it's not in the bottom. So when we come back to this problem, again, we now need to multiply across. So I will have 8 square roots of 3a. And on the bottom, when I come over here, I'm still going to have this negative 6 on the outside. I'm going to go through this multiplication a little bit slower, right? Since this is like a 1 here, so negative 6 times 1 is what's giving us this. And then when I multiply my insides together, 3 times 3 would just be 9, and a times a is a squared. And if I wanted to simplify this piece, 3 and 3 is what 9 is, and a squared is just a and a, so I can pull a 3 out to the front, and I can pull an a out to the front. So, doing that, my numerator is not going to change yet. And in my denominator, now I'm going to have a 3 out front with the negative 6, so 3 times negative 6 will give us a negative 18. And I'll also have an a out front. And since there was nothing left inside of our square root over here, there was nothing left inside, it all got pulled to the outside, there is no square root left down there. Another way to think about this would be to say that if you really understand that multiplying a square root by the same square root undoes it, when I multiply these two pieces together, basically what's going to happen is I will be left with just 3a. The two square roots are going to cancel each other out, and we're just going to be left with whatever was inside one of them. The negative 6 drops down. Negative 6 times 3 would give us, my iPad's being a little weird. 1 second. Negative 6 times 3a is going to be, of course, a negative 18a, which is what we already saw down in our denominator. Now, there is, of course, a little bit more simplifying that we can do here, and that has to involve these two numbers right here. And what we think to ourselves is, if I have the fraction 8 over negative 18, could it be reduced at all? And when we do, we're just trying to look and find the number that goes into each of those that's the same, and the biggest, of course. So we know each of these could be divided by 2, which would then leave us with 4 square roots of 3a over a negative 9a. And we're done. Again, we can't reduce the bottom with what's inside that radical, the 3a there, because of the fact they're insides and outsides. Let's do one more problem like that, and then we're going to kind of pivot a little bit here. So looking at this one, again, our goal is simply to get rid of the square root in the bottom. The fact that there's already a square root up top, that's okay to us. We don't care all that much about that guy. It's the one in the bottom that becomes the issue. So if I want to get rid of the one in the bottom, I need to multiply by the square root of 9x to the bottom, and up top, the square root of 9x. Multiplying across, remember with fractions, we multiply the outsides and the insides, so I will have a 4 on the outside because that didn't have anything to combine with, and 3 times 9x will give us 27x. In the denominator, we'll have a 2 on the outside because, again, that didn't have anything to combine with. And since I am multiplying by the same square root there, we know that we'll be left with just 9x at the end of the day. So this is really 2 times 9x. Simplifying this out a little further, we will have 4 square roots of 27x over 18x. Now, we still should go through and simplify if at all possible. This square root can definitely get a little simpler. So if I look at the square root of 27, If I were to do my prime factorization tree, that would just be 3 times 3 times 3 times x. We can pull out a pair of 3's. So if I pull a 3 out of there, I'll be left with a 12 on the outside because I already had that 4. 4 times 3 gives us a 12. And I will be left with 3x still inside. So my new simplified form of this will be 12 square roots of 3x. And on the bottom, I will have 18x. Looking at any last simplifications we can do, 12 and 18 can be reduced to 2/3. And we are complete. Nice work. Again, rationalizing the denominator is all about getting rid of the square root in the bottom. So we don't need to worry about square roots up top there. We deal with them, we work through the problem, but they don't affect how we go about it. What drives this problem is whatever square root is down here. That is why we multiplied by this. Now, in some problems, what we're going to find is that in the denominator of our fraction, there's actually a plus or a minus. And that actually starts to pose a problem, and we need a new tool to work with that. And that new tool that we get to deal with is what we call conjugates. Now, conjugates are just the sum and difference of the same two terms. It says multiplying a binomial that contains a radical by its conjugate will eliminate the radical. So right here we can see a really simple example of two conjugates. And really what we mean when we say two conjugates is it's the exact same two terms, except one has a plus, the sum, and one has a minus, the difference. Same two terms, one with the sum, one with the difference. And when I multiply those two things out together, I'm going to try to color code this because that's what's happening here. These are being multiplied. 3 times 3 gives us the 9. 3 times negative 11 gives us the negative 3. 3 times a negative square root of 11 gives us a negative 3 square roots of 11. When I multiply the square root of 11 by 3, I'll get a positive 3 square roots of 11. And lastly, when I multiply the square root of 11 by the square or a negative square root of 11, that will end up simplifying to be a minus 11. Now, once I'm at this point, it's important to notice that negative 3 square roots of 11, when added with a positive 3 square roots of 11, those two pieces completely cancel each other out. And all you're left with is 9, take away 11, which is negative 2. Now the big picture idea here is the fact that our radicals that we started with are no longer in the picture. We are left strictly with a whole number, which is why this becomes incredibly important for the idea of rationalizing the denominator. So, down here, if I wanted to deal with this problem, and this has to happen anytime you see a plus or minus in the bottom that you need to use to conjugate. And before we do, let's just look at what would happen if we tried to do this without. If I said, well, I want to get rid of the square root of 5 in the bottom. Again, this is the wrong way. Don't write this one down. But if I looked at this and I tried to multiply this all out, I would end up with the square root of 15 up top. And what happens here is that this is a quantity. So this square root of 5 needs to multiply to here, but it also needs to multiply to here. So when I take 7 times the square root of 5, I'm left with 7 square roots of 5. And if I multiply the square root of 5, or negative square roots of 5 by the square root of 5, I'll be left with the negative 5. And what you notice is that what we have here isn't all that different from what we started with. We still have a square root in the bottom. We didn't get rid of it like we wanted to. We just moved it around. And that will happen every time I try to continue that process. So this process no longer works on problems that are more complex, that have that plus or minus in it. So instead, what we have to do is we have to go back and readjust our thinking. Whenever we see something that has the plus or the minus in the denominator, we need to multiply by the conjugate. Again, since this is a minus, then the conjugate would have to be a plus. And whatever we multiply the bottom by, we have to multiply the top by, because this is really just the idea of a 1. And when we multiply by 1, it doesn't change anything. Now, up here, we want to think about these all as quantities right now. So let's put our parentheses around so we can make sure we distribute appropriately. We are going to take the square root of 3 times 7, which will give us 7 square roots of 3. When we take the square root of 3 times the square root of 5, we will get a positive square root of 15. Coming across on the bottom, this is where our multiplication will be a little bit more difficult. 7 times 7, both positive, will be 49. A negative square root of 5 times a positive 7 will be a negative 7 square roots of 5. Remember, outsides don't change insides, insides don't change outsides. When I take 7 times the square root of 5, I'm going to get a positive 7 square roots of 5. And when I take a negative square root of 5 times a positive square root of 5, we're going to get a minus 5. Right? And again, the reason for that, negative square root of 5 times a positive square root of 5, two square roots are going to cancel each other off here, and we're just going to be left with whatever was inside, and that negative will drop down in front. If you've made it this far, it should be relatively clear to see that these two pieces, your 7 square roots of 5, will cancel each other off because one is positive and one is negative. 49 take away 5 will leave us with 44. And up top, we'll have 7 square roots of 3 plus the square root of 15. Square root of 15 can't be simplified because it's just 3 times 5. Square root of 3 can't get any smaller either. Those two pieces can't be combined because they don't have like radicals. This is as good as it gets, ladies and gentlemen. Not quite as pretty as what we were starting with before, but we have in fact eliminated the radical from the denominator. Looking at the next problem here, we have 2 plus the square root of 8 in the denominator. So in order to get rid of that, we want to multiply by, not equals, times 2 minus the square root of 8. Since this was positive, this needs to be negative, or minus. In our numerator, we will have 2 minus the square root of 8. And again, these are all quantities, which is why you're seeing me put parentheses around everything. Distributing this 2 across the top, we'll have 2 times 2, which is going to give us 4. And 2 times a negative 8, which will give us a minus 2 square roots of 8. Across the bottom, this is where it's always going to be a little harder. So let's try to color code this better for you. 2 times 2 is going to give us a positive 4. 2 times a negative square root of 8 would be a minus 2 square roots of 8. Square root of 8 times 2 will be a positive 2 square roots of 8. And lastly, square root of 8 times a negative square root of 8, this is where your two square roots are going to cancel each other off, will be a minus 8. Now, if you get this far and you notice that your middle two terms don't cancel each other off, right? They're not the same but opposites, then you made a mistake in your distribution. These will always cancel in this type of a problem. Which leaves us with 4 minus 2 square roots of 8. And on the bottom, we have 4 subtract 8, which would be a minus 4. Now, there is still a little additional simplification that we can do here. 8 can be broken into 2 times 2 times 2. If we did our 2 for 1 special, we can pull out a 2. 2 times 2 would give us a 4. So we will have 4 minus 4 square roots of 2, because that's all that was left inside. And on the bottom, we have a negative 4. Now, this fraction can actually be broken up. Since all of this is being divided by 4, this is equivalent to the idea of saying 4 divided by a negative 4, right? So that's basically like saying, let's move the 4 over to here and kind of break that fraction apart. Minus, this is the minus that we're seeing still, the top half on the other, 4 square roots of 2, divided by a negative 4. And the reason we like to look at it that way is because then we can see this and say, well, 4 divided by a negative 4 is just a minus 1. So we have negative 1 minus, again, we have 4 divided by a negative 4, which is a minus 1, square root of 2. Last but not least, these two negatives make a positive, so we'll have a minus 1 plus 1 square root of 2. Right, so right now, even just on day 3 of new material, there is a lot of math that is going on. There's a lot that we're expecting you to remember and to be able to use at this point in time. And that shouldn't scare you, but it should just really make you say, I got to put the work in right now so that I can continue on as we continue through this course. Here's another problem. Again, we see that we have a square root in the bottom. Our directions are to rationalize the denominator, so we need to get rid of it. Hopefully you're saying, well, since this is a minus here, we need to sit there and multiply by the conjugate, which means I need to use the plus version. Now, again, we are dealing with quantities here. So these are all quantities, which means we got to be really grounded in those basic radical skills. So multiplying across the top, 2 times 4 is going to give us 8. 2 times the square root of 3 is going to give us a positive 2 square roots of 3. The square root of 3 times 4 is going to give us 4 square roots of 3. And the square root of 3 times the square root of 3, again, we have 2 of the same square roots being multiplied together, so the square roots drop off, and that becomes just 3. Now, looking across the bottom, 4 times 4 is going to give us 16. 4 times the square root of 3 is going to be a positive 4 square roots of 3. Negative square root of 3 times 4 will be a negative 4 square roots of 3. And lastly, negative square root of 3 times a positive square root of 3 will end up just being a minus 3. I'm hoping that those color coding kind of helped you piece together what's happening in each of those multiplications. Remember, you're always allowed to pause this video and rewind or slow it down, whatever you need to do to sit there and grasp these materials. I know in class you'd be able to ask questions, and of course in this format we can't do that, so it makes it hard. But please, you can always email me too if you're going through this and saying, this isn't clicking right now. I need a little bit more of a refresher. So let's just start simplifying. Let's start up top. Of course here, 8 and 3, we know that those can be added together to give us 11. Those are like terms. We also have like terms right here because they have the same radical. 2 square roots of 3 plus 4 square roots of 3 would give us 6 square roots of 3. Looking across on the bottom, sorry, the lights just turned off in my room. 16, take away 3, would leave us with 13. And 4 square roots of 3, take away 4 square roots of 3, cancel each other off. Making this our final answer. We're fine keeping our answer here. We don't need to break up that fraction like we did in the last problem because of the fact 13 and 11 don't have any common factors, so they're not going to be able to be reduced. And neither do 13 and 6, right? In the last problem, everything was like a 4 at this point in time, which is why we broke it up. We knew those could be reduced. Last problem we are looking at is right here. Again, we have a plus in the bottom, so we need to multiply by the conjugate, which will have a minus. So we'll have the square root of 5 minus 1. And up top, square root of 5 minus 1. Make sure you put on all your parentheses. You are dealing with mathematical quantities. And then we start to distribute. The square root of 6 times the square root of 5 will be the square root of 30. The square root of 6 times a negative 1 will be minus 1 square root of 6. Across the bottom, square root of 5 times the square root of 5. Like radicals multiplied together, the radical signs drop. And we're just left with 5. And then we'll have the square root of 5 times a negative 1, which would be a negative square root of 5. 1 times the square root of 5 will be a positive square root of 5. And 1 times a negative 1 will be a minus 1. Now, just as we expected, the square roots of 5 will cancel each other out. So we're just left with 5 take away 1, which is 4. Up top, these two are not like radicals, so we can't just put them together. But we might be able to simplify them at this point. So let's break down 30 for a second. Thinking about 30, 30 is just 15 and 2, and 15 is 3 and 5. And we're at our prime factorization, so it's really 2 times 3 times 5. Notice how we don't have any pairs. That can't get any simpler. 6 is really just 2 times 3. Again, no pairs. That cannot get any simpler. So in fact, it turns out that this, although it looks like it maybe could go a little bit further, is actually as good as it gets. Again, ladies and gentlemen, I'm expecting you to have questions on this, and that's okay. Please reach out to me. I am happy to help and be of assistance so we can get you moving in the right direction on this. Thank you for watching. Have a good day.